Welcome to this session. This is electrochemistry. So we have this question. An electrochemical cell consists of 1.0 liter half cells of iron and cadmium with the following initial concentration. So we have that of iron and that of cadmium respectively. The first question is for us to write the overall cell reaction. So if you want to write the overall cell reaction, the first thing you have to do is to write the two half reactions. So the half reactions, one is the reduction reaction, the other one must be the oxidation reaction. Now in this case, we are not sure which one is the oxidation and which one is the reduction reaction. So if you want to know which one is the oxidation among these two that we have, cadmium reaction as well as iron, which one is the reduction reaction? So the reduction reaction, it always have the reduction potential greater than that of oxidation reaction. So if you look at the two, you find that iron is having less reduction potential compared to that of cadmium. Therefore, cadmium is the reduction reaction. Iron is an oxidation reaction. So in this case, when we want to write the half reaction will appear like this. So the first one we are going to write is the oxidation reaction. So the oxidation reaction for iron, it will be iron solid plus iron solid producing iron 2 plus aqueous plus the 2 electrons. So always, if it's an oxidation reaction, the electrons are added to the right hand side of that half reaction. Then this one is the reduction reaction. So it will be CD 2 plus aqueous plus the 2 electrons. What we are producing is just the reduced form of cadmium. So this side it will be solid, and then this is the reduction reaction. So now that we have the reduction and oxidation reaction, we just have to counter check if the electrons are balanced. So in this case, all the 2 electrons are balanced. The next step is for us to cancel out these electrons, and then after that we need to add the 2 half reactions. So by adding, we mean we need to add the reactant on one side as well as the products on one side. So in this case, what we have as reactant is iron solid plus cadmium 2 plus aqueous. We are producing cadmium solid plus iron 2 plus aqueous. So this is basically our overall cell reaction. So this is our overall cell reaction. Alright, so now how can we calculate the initial cell potential at 25 degrees Celsius? So now the first thing, we need to recognize the fact that we need to use what we are calling as the Nersnst equation. So question number 2, the Nersnst equation states that Ecell is equal to the Ecell at standard potential minus 0.0592 over n log Q. So this is the equation that we need to use. So you call this equation as the Nersnst equation. So first of all, we need to identify what we have. In this equation, N is simply the number of electrons transferred. So this is the number of electrons transferred. Okay, so now in this case, if we go back to the number of electrons we transferred, here in this case we only exchanged 2 electrons. So the ones that we cancelled out, these are the electrons that we can transfer. So in this case 2 electrons were transferred. Now Ecell, this Ecell we need to calculate. So the Ecell is equal to the standard potential for cathode minus the standard potential for anode. So this is the equation for Ecell. So in this case, we have the standard potential. We have identified that the first one, ion, is the oxidation, and then this one is the reduction. So therefore the standard potential for reduction, which is the cathode, is 0.04. So we are saying negative 0.40 V minus negative 0.44 V. So now when we punch that, what are we going to have? Okay, so when we add, we are expected to get positive 0.4, no, positive 0.04 volts. So this is our Ecell at standard temperature and pressure. So now that we have everything, we can simply replace. And then before we do that, we need to recognize the fact that Q is simply the concentration of products over the concentration of reactants. So now this will take us back to the overreaction. So observe that what we put there is just the concentration which you have been given. So in this case, the concentration of product is that of ion. So ion is the product in this case, and then the cadmium 2+ is the reactant. So what we are going to have is the concentration of ion 2+ over the concentration of cadmium 2+. Remember that these do not have coefficients, so you just simply replace with what we have over 0.2 molar. So now this will basically give us 4. This will give us 4 as the value of Q. Now after that, we just have to substitute what we have in our main equation, and then we calculate. So we know to say Ecell. So Ecell now is equal to the Ecell at standard we have calculated to be 0.04. So it is 0.04 minus log, or rather sorry, minus 0.0592 over n is 2 log 4. So since Q is 4, we just punch in and get. So try and punch and find out what you are going to get. So you can pause the video and punch. So you expect to get positive 0.022. Hope my calculation is correct. So that is how we need to handle such a question. Then the other question is number 3, which is basically on the other question is on free energy, enthalpy of free energy. So this one now is equal to negative NFE at T standard. So this is the equation we use, where N is still the number of electron transferred, F is the Faraday's constant, E is the Ecell that we calculated. So we can find this to be negative 2 times, so this F is the constant, so the F is the constant. Okay, so F is basically the constant, so we just have to substitute, which is 96,500. So now in other books this constant can still change, and then we also have the Ecell, which we found to be 0.04. So now after that we just punch and get our final answer. So our final answer will be somewhere -7, 20 joules per mole. So this is our free energy. Now lastly, the last question is they want us to calculate the time required for that reaction to produce that, or to use up that 10 grams, to produce that 10 grams of mercury nitrate. So one thing for sure, whenever you have such a question, we can always come up with there is a short way of solving just by writing. One formula can cater for everything. So we know to say time or mass of the substance. So M, so this mass is in grams. Yeah, so we know to say mass can be calculated using the equation which states that mass is equal to Q multiplied by the molar mass over NF, where N still is the number of electron transferred. So now, what do we have here? We know to say our mass is basically 10 grams. Excuse me, is equal to the Q. We are looking for Q first so that we can find time, times the molar mass of silver nitrate, which is 259, over the N being transferred to electrons times 96,500. So now to get Q, so in this case we make Q the subject of the formula. So let's try and calculate what Q is. Okay, perfect. So now in this case our Q is equal to which is 9621 is my calculator working well? Okay, 9621.6. So this is our Q. Now we know what Q is from the formula, so we know to say Q is equal to IT, which is current times time. Therefore, if we want to get time is equal to Q over the current. So in this case we are saying Q is equal to 9621.6 over 0. Because according to the question the current is 0.17. So therefore if we punch now, divide by 0.17, we expect to get 5,659 7.7 seconds. So this is the time in seconds, which you can simply convert to minutes if that's the case. So to minutes this would be somewhere 9:43 minutes. So this is how you attempt such a question. Thank you so much. Always feel free to contact me on 0970 94 10 96. Bye for now.